Welcome, everybody. We have an ambitious agenda today. I'm very pleased to co-teach this with you. Co-teach this with my colleague Elias Puranen. And of course, teaching AI in one day is a bit beyond our scope. But what we're trying to do today is focus on data literacy and data skills. I'm sure most of you have read the news recently on the alarm bells being rung by Jeffrey Hinton, who's considered one of the pioneers of modern AI, on how we're evolving too quickly in our development of AI tools and use. And why I started this program in Wattspeed was to create an opportunity for individuals with limited coding and statistical expertise to really dive into this type of education and learn how to code, learn how to tell stories with data, and understand what artificial intelligence is. And from a very small perspective, limited perspective, well, artificial intelligence, of course, is vast, but at the heart of it, artificial intelligence deals with methods which allow us to code and give directions. And one of the workhorses, one of them, in order to accomplish that, are what we call regression models, which have been in statistics for many, many years. So, what we're going to do today is that we'll start off with discussing what regression models are, and we will, of course, first focus on summary statistics, because before you go jump into AI, you have to have a bit of statistical foundation. And that's what we've tried to do in our three-course program. So we'll start off with looking at summary statistics, go on to regression models, and then go on to a demonstration of coding using R. And I'll see how much I can cover, but what I'll try to get to is showing you multivariate regression models, which are very common in machine learning, and give you examples from my research and how I use them to address what I think are important policy questions, along with showing you how to code these concepts in R, which is a free language and very easy to use. And after I finish, Elias will be taking over the afternoon session, and he will be looking at an alternate coding language called Python. And I'm sure most of you heard about Python and R, just to give you some variation out there. But the way he accesses Python, you'll see, is actually very similar to the R setup. So there's a lot of overlap between the two. And he'll be able to get more into machine learning, which is not the only form of artificial intelligence. That's very important to emphasize, but these days is the AI which we hear the most of. And the way I will be teaching is that I'll be using our Learn website from the University of Waterloo, where all our material is. And I will be showing you how our courses are set up, and I'll be teaching you modules from the course. So I'll be sharing my screen, and I'll try to stop every half an hour to 40 minutes to see if there are questions. Ethan will be assisting me in that respect. And I will also give you some live coding examples using R. So that's roughly how I intend to teach. Try to make it as simple, as notation free as possible, and also try to make it interactive. So I will hopefully be able to take questions from you and address clarifications. And if we'll do a poll at the end of my teaching, if any of you want office hours. So the way the morning is set up is that I will continue till about 10:30. We'll have a half an hour break. I'll start again from 11 o'clock to 12 o'clock. Elias will start at 1:30, but if some of you want to chat with me, to network, um, to ask me questions about what I taught, or you'd like to discuss something project at work, I'm happy to have, um, shall we say, office hours from 1 to 1:30. Okay. And Ethan will conduct a poll. And if we get quite a few people, I'll be happy to do that. So without further ado, let us now begin. So I'll start by sharing my screen. Okay, so Ethan, I'm just asking you if you can see my Learn site.
Yes, looking good.
Okay, that is great. So this is the Waterloo Learn site, and at the university, this is where all our courses are hosted and where we manage to teach online or convey information to students. So here in my panel out here, you see the two courses which I developed for the WattSpeed certificate. And I will start with the basics of modern statistics and analysis. And this is the first course in the WattSpeed certificate. And there are 8 modules. Each module takes 1 week. So as you can see, we start off with the very basics of statistical analysis, looking at means, medians, standard deviations, and then going on to distributions, confidence intervals, then stopping to train students in R, and then going on to linear regression models. Okay, so what I'll do is I'll start off with module 1. And in module 1, I will go to 1D, what is the story? Now, the way this course is set up is that it's based on the use of Statistics Canada data, open data, CanSIM, accessible through CanSIM, which I'm sure many of you know about and use almost on a daily basis. So what I've done in this course is that I've constructed some examples from my research. And in my research, what I'm interested in is understanding the determinants of poverty in the country. And these modules are set up to look at poverty among lone parent households. So what I'm using is not the official measure of poverty in the country, but it's the low income cutoffs constructed by Statistics Canada. So it's the percentage of people, of individuals who fall beneath threshold. And so I interpret that as being in poverty. And looking at individuals who are heads of lone parent households is particularly important because of high poverty rates in this particular demographic. So I'll go straight to, you can see each module is divided into subsections. So I'll just go straight to the story. So what is the story here? Now, here's some notation. I will not spend time on notation. I'll just explain the concepts very simply. So what we want to do is imagine if I was a research analyst, and this is exactly how I teach my students. In the statistics course I teach as part of the Master of Public Service program. And I do wish to acknowledge support and sponsorship from the Master of Public Service program, as well as Waterloo AI. Now, suppose you're a research analyst and your manager asks you to look at the relationship between minimum wages and poverty rates. And say you want to start off simply and you look at 2 provinces, Ontario and Alberta. And the idea here from a policy perspective is that you really want to reduce poverty rates among lone parent households. So if we legislate higher minimum wage rates in the country, can we infer some type of relationship? And we're not going to start off by saying causal relationship, just some type of relationship. So we want to look at averages and standard deviations between provinces, and we also then want to look at correlations. So in terms of correlations, I think most of you do know that correlations are bound by being between -1 and +1. If you're at the extremes of either +1 or -1, that's really high. Your variables are very correlated. So correlations give you a relationship, a number relationship between two variables, okay? And the closer you get to 0, the lower the correlation. So that is the simple explanation out there. And that's all we need to know. So what I want to do as a research analyst is that I've collected the data, and you can see the data in front of you. So I've just collected data, say, from 1990 to 2011. And you can see that these are data which may be on an Excel spreadsheet. And you can see that in year 1990 in Ontario, the poverty rate for this demographic was about 37.6%, and this was the minimum wage in real terms. In the same year in Alberta, you can see that the poverty rate was much higher, but the minimum wage was also a bit lower. So in order to make any inference about relationships, what we want to do is we want to make comparisons as a social scientist. We want to make comparisons across jurisdictions. We want more and more examples, but we also want to see what happens within jurisdictions over time. And so that'll help us to tell the story before we even start our more complex, begin our more complex analysis. When I look at the data in front of me, I notice some interesting trends. The first thing is that for quite a few years, the poverty rate in Alberta seems to be higher than in Ontario. And again, this is just for lone parent households. But when you look at the data over time, you see a very kind of steep decline in the poverty rate for Alberta. So by 2011, it's about 17%. Now, on the other hand, in Ontario, you also see a decline in the poverty rate. And you get to, I'll just focus on this number here. I'll say that it's somewhat comparable between the two provinces, but there seems to have been a sharper decline in latter years in Alberta relative to Ontario. Now, in terms of the minimum wage, well, that's gone up on average throughout the years. And in Ontario, it's a bit higher than in Alberta. So what can we summarize so far? Very sharp declines in poverty in Alberta, declines in Ontario also, not so much, but there are declines and there are increases in the minimum wage. Is there then a relationship between the minimum wage and poverty rates? So what I'll do first is just look at the summary statistics. So in my research, I always look at the mean, median, and standard deviation, right? The mean is just the average. The median is, again, also a measure of central tendency and sometimes good to look at if your data are skewed. And a standard deviation basically gives you the spread, right, of your numbers. And when you look at the data, what's interesting is that when you look at Ontario and you look at Alberta, you see that the means are very similar in terms of the poverty rate. The average minimum wage is higher in Alberta, in Ontario, I beg your pardon. But what's also interesting is the median is lower. The median poverty rate is lower in Alberta, and that's because then in Ontario, and that's because the poverty rate fell very sharply and dramatically. So that's why the median is actually lower than the mean in this case. And the median poverty rate in Alberta is lower than Ontario. Now, that's also reflected in the standard deviation. You can see that the standard deviation or the variance of the poverty rate is higher in Alberta than in Ontario, okay? So on the other hand, when you look at the mean and medians of the minimum wage, they're not that different within provinces. And you see that it's slightly higher in Ontario than Alberta. So what you're seeing, what I'm attempting to do is that I'm attempting to tell you a story, what's going on. And as the final step here, what I'd like to do as an analyst is look at the correlation coefficient, right? Which gives me an idea of the relationship between the minimum wage and poverty rate. And you can see what's interesting here is that it's negative for both Ontario and Alberta. So what it's telling you that as the minimum wage is going up, it's associated. Remember, it's not causal. We'll be very specific about that. As the minimum wage is going up, then the poverty rate is going down in Ontario and in Alberta. But you get a much higher correlation in Alberta, 0.6. I'd say this is getting to be high, than in Ontario, which is pretty modest. Okay. So that is the story which comes from just looking at summary statistics. Okay, so I will stop sharing my screen for a minute. And so the idea then now is that what are the next steps, right? And what the next step should be is that we're just looking at the effects of the minimum wage on poverty. Now, we haven't done that yet. We're looking at the relationship. We want to look at more complex modeling, which will allow us to say that, you know what, if the minimum wage increases by $1 an hour, controlling for other factors, what is the effect on the poverty rate? That's where we want to go in our data analytics journey. Okay, so that can be accomplished through regression analysis. Now note, I'm still not saying cause. I'm not saying that a $1 increase in the minimum wage causes a certain response in poverty. Regression analysis doesn't necessarily give you that. But what it does, it gives you more robust correlations. Okay, so I will now stop for 2 minutes just because I want to, and Ethan, if you could assist me, please, if there are any questions.
We don't have any content questions in the chat right now, but at this time, we will give it a minute. If anybody does want to ask a question, please feel free to post it in the chat or take your microphone off mute.
Yes, please, can you tell me if this pace was okay? Was I clear? Would you like me to continue in this manner? Any type of comment or feedback would be most welcome.
Some comments are saying that you've come through clear. Yep. If you would like to go a little bit faster, that's okay, but we can get.
Okay, great. So I will go. Okay, thank you. Okay, good, everybody. Thank you so much for your encouragement. So I'll go slightly faster then. And if I'm going too fast, I will stop and just let me know and I'll dial it back a bit because I just want to cover a lot of material and give you knowledge by the time I end. Okay, so what I will now do is going back to my example. And so you can see, so now we're going to do a bit of skipping, okay? Okay, so what I've done is that I've summarized a bit of module 1 in the course. Now, there's some great stuff in between, but which I don't have time to do. I will get to coding, but what I want to do is that I will jump to module 5, which is the linear regression model, okay? And what we'll do is we'll look at the same story. Okay, so I will start off with 5A, the linear regression model. Now, So this is notation, and I'm not going to get into uh, significant detail, but at the end of the day, what are we trying to do? So what we're trying to do is we're trying to formulate an equation, right? So what an equation consists of is your dependent variable, which is called y, and your explanatory variable x, okay? And so in this case, what given our example, what we want to do is we want to look at the effect of the minimum wage on the poverty rate. So xi will be our minimum wage and y is our poverty rate. Now, the idea is then to get an estimate of what is called the coefficient beta 1. Okay, that's what we want to get an estimate of, because this beta 1 will tell us that what is the effect. Well, let me dial that up back. That if X, which in this case is minimum wage, increases by $1, what is the response in your poverty rate? So an estimate of your beta 1 will give us that. So we need a method to get us an estimate. Now, you don't have to worry about beta 0. In most cases, it's a value of y when x is equal to 0. So it's not important for us at this stage. What is really important is this term called u. Okay, so u is called the error term, and the reason why we have as statisticians we put an error term is because we know that when we're trying to explain a dependent variable, we can never control for everything which could possibly affect your dependent variable. And therefore, those factors are captured by what we call U is the error term, because there's always some error which a statistician always commits, something we haven't controlled for. So what we want to do theoretically is really minimize the effect of this error term, right? And the reason why you have these I's is because it tells you how the data are organized. So at this time, suppose that we're looking at data for the same year across different provinces. So the I could represent each of the 10 provinces of Canada. That's just an example. Okay, so that's all we have to know about equation 1 for now. Okay, now what it is that the big picture is we're going to look at, we're going to use something called ordinary least squares, right? That's basically the way we get an estimate of the coefficient beta. So when you think of it, it's a straight line. You see this, and if your y-axis are your values of y, and these are your values of x, what we're trying to do is we're trying to theoretically minimize the error term. And we do that, one way to do that is trying to draw a straight line through your data points, okay? In this example, what we're seeing is that at the end of the day, when I'm estimating this equation, it's based on many, many observations. So this beta 1 is an average response. Across all the data you have, can we summarize what the effect of an increase on the minimum wage is on poverty rates? So you can imagine then that we have all our data points, because each y as will be matched to an x. Now, you saw that in the previous slide when we looked at data on poverty rates. for Ontario and Alberta. We had values for each year. So if we plot them out, here's an example saying that if we had this average and the line was just going up, then this is the error. Like we're off out here by quite a bit. That if this is an actual value and this is our average, then that's not so good. That's an error. And we need to minimize this. And I'll just quickly show you, this is kind of what I'm looking at, is just trying to draw a line, okay? So I'm gonna come back to that later. Okay, so this is what the data looks like, right? And this is for Ontario. And this is what I meant, that we need to organize data in, say, a spreadsheet in a certain way that your X and your Y are matching. And they are, because you have these values now for each year. Okay? Now, going to 5B. So that gives you an idea. So let me summarize. We're using, what is a regression model? The regression model allows you to get estimates of the relationship between an X variable and a Y variable. It's based on data. You'll take the data and you will then use an algorithm, right, which allows you to get an estimate of this beta 1, which is the slope. And it's based on minimizing the errors, which you see, okay? So we're trying to essentially get a line of best fit. Now, this will become clearer in our next module. So what I tried to do is give you some intuition. And we used a method called ordinary least squares to get an estimate of your betas, right? That's what we're after. Now, again, I will not get into details into this, but this gives you the statistical foundations of what you're trying to do. Now, I will only show you this formula here. Now, this looks pretty terrible, but I'm going to try to simplify this for you. What it's telling you is that if we use the method of ordinary least squares, it allows us to get an estimate of beta 1 hat. The beta 1 hat simply becomes a formula, right? As you know, for a simple mean, you have a formula, the average. You sum up all the values of a variable and divide it by the number of observations. It's exactly this in the same type of spirit. What this is telling you is that in order to get your estimate of beta 1 hat, you need to look at your data. You need to see how each value in your data set differs by the mean, right? That's true for your X variable and your Y variable. And then you multiply it and add them up. And I'll show you this example just now. And that's divided by taking your each value, subtracting it from the mean, and then squaring it and adding it up, okay? And once you do that, you get your estimate of beta 1 hat. So let's now do it with a simple example, which I hope will be very illustrative. And, it'll show you we can get rid of this notation, we can get rid of this algebra, and that formula is actually really simple to implement. Sorry, just had to have a sip of water. So here is data from Ontario, and each row refers to a value for a certain year. And so we have so many observations, okay? Now, The Y value refers to the poverty rate for a specific year, and your XI refers to your minimum wage value for a certain year. Okay, so for the same year, right? And this is year after year after year after year. So looking at these different values of variables, Y bar, the mean of Y is 32.5, and X bar, which is the mean of X, is 7.40. Okay, so you can just calculate that very simply using a calculator or Excel. Now, what we're going to do is that you take this value of Y bar 32.5 and you subtract 37.6 minus 32.5, 46.1 minus 32.5, so on and so forth. And similarly, you take the mean of X, which is X bar 7.40, which you see here, and then you subtract X bar from each of these X values. And then you multiply the subsequent results. And when you do that, you can see for the first row, I get a value of negative 4.69. And then the second row, negative 9.93, and so on and so forth. Now in this column, all I have to do is that I take Xi, each of these values, and I subtract it from the mean of 7.4. And then I just square it. And then I get these corresponding values. Now, this is good. We've done our first steps. But if you notice the notation out here, you see this Greek symbol, which is basically sum, summation. Now that tells me that I have to add all these values up. And when I add these values up, this is the numerator I get, minus 36.96. And this is the denominator, 7.36. So all I do is I substitute it back into this formula, as you can see, right? The numerator is negative 36.96. The denominator is 7.36. And when you do that, you get the value of negative 5.02. What does this now mean? Well, congratulations. You now have an estimate of what is the effect of a change in $1 change in the minimum wage with respect to the poverty rate. Telling the story with data and data analytics. The way to interpret this is that now the coefficient estimate beta 1 hat implies on average, you're saying on average because your results are based on many observations, different provinces for different years. So the coefficient estimate implies that on average, a $1 per hour increase in the minimum wage is associated, you could say correlated also, is associated with roughly a 5 percentage point drop in the percentage of families under the low income cutoff, right? So this so far is suggestive that if you increase the minimum wage by $1, it is associated over time with a non-trivial decline in the poverty rate in these provinces. Poverty rate among lone parent households. Okay, so this is the type of output you can get from a pretty basic approach and simple formula. Okay, so I will now stop here for 2 minutes. Ethan, are there any quick questions? I just want to make sure I haven't left anyone behind, and we're all sort of following this, and it's okay. So Ethan, could you please assist me in reading some questions?
Yeah, so the only question that we have right now in the chat is asking how somebody could have access to the link that you've just been sharing, which I know is the Learn platform. So Ananda, do you want to touch on how that works?
Yeah, I'm sorry. I'd love to give you the link, but this is proprietary. So what I'm showing you is straight from the courses we teach. So I can't give you the link, but of course, if you enroll in the program, would be love to have you as a student. Now, I want to kind of stop. Is our learners sort of okay? Do you have any questions on what we've done so far?
Getting quite a few thumbs up from
Okay.
the learners and some
Okay.
comments that we're looking good.
Okay, so I think that we're okay so far. And if it's okay with you, I shall then continue and I'll stop again soon. Okay, so now the fun really starts because, and Ethan, I think someone's trying to enter the room.
Yeah, don't worry. I'll keep letting them in.
Good. Okay, good. Okay, so now let's start the coding. So this is really fun. Okay. So let me just look at my notes to make sure that I'm covering the stuff. Okay. Let me share my screen. And so go to my window. And first I'll do, okay. So what I want to do now is that, let's run some coding. So here's my data sheet. And you can see my data sheet. And here's a poverty rate we're using. Here's a minimum wage. And what you can see is that I have data, I think, for 5 or 6 provinces from 1990 to 2011. So I have data for Nova Scotia, Quebec, Ontario, Alberta, and BC. Okay, so I have a data set of about 110 observations. And so, for the purposes of this exercise, that's not a bad data set, okay? I know we have big data sets of millions of observations, but for this type of policy analysis, this is not bad. And what I want to analyze, as I said, is the relationship between the minimum wage and poverty rate. Now, there are a couple other things out here which I want to point out. There are some variables. So government transfers is, again, so all these data are from StatsCan. And government transfers shows you the annual transfers to low-income households, right? So I want to put that out there. And also employees, just the employment rate and population employment rate. And the idea here is that, look, so far what we've got is an estimate. Well, the preliminary analysis suggests that there's a relationship between the minimum wage and poverty rate. Higher minimum wage, lower poverty rates among lone parent households. But really what we want to do is we want to see how robust it is, right? Because we're just focusing on one right-hand side variable. Now, the beauty of regression analysis is that we don't have to restrict our analysis to one variable, right? When you look at correlations, you look at the correlation between y and x. But with regression analysis, since all we have to do is keep including more variables on the right-hand side, what's going on is that we can look at the effects of the minimum wage on poverty rates, but controlling for other factors such as government transfers and employment rates, right? Because at the end of the day, surely as government transfers become more generous, that should have an impact on poverty rates independent of the minimum wage. The same logic here, that as the employment rate goes up, the economy is getting more and more healthy, then the poverty rate should go down. So if we include these variables, does our relationship, does the effect of minimum wage on poverty remain robust? Okay, if we want to get at that, then what we have to do is we have to do some coding. So now I'll introduce you to a bit of R. So the first thing is that R is free, and which is so great. And it's such a lovely language and easy to use interface. And all you have to do is you have to go to this website, posit.co, and download it. And you have to download two features. So one is you have to install R. So this basically then installs, it basically installing the calculator on your laptop. But then you have to have an interface, right? So the way to code is done through an interface, and the interface I use is RStudio, and it's very similar to Spider, which is used for Python, and Elias will use later today. Okay. So having said that, now what? Where is it? Okay. So having said that, let me show you what R looks like. Okay, this is it. So I'm sorry the font is a bit small, um, but essentially how R works is that I won't get to everything, but just quickly, here in this left-hand corner is where I just put all my commands, okay? And then what happens is that whether the commands are processed or not comes here at the bottom. And then on the right here, the environment tells me what data sets I'm using, how many observations I have, how large my data sets are. So in today's world of data science, we use more and more of the data science terminology. So when you look at data sets, usually we call them rows and columns. The columns are the variables, which I showed you, the minimum wage, poverty rate, those are columns. And the rows tell you how many values you have. So in the data set which we're using, the rows are the values for each province for each year, okay? And here in the bottom right, it shows you the graphics which I can create. Okay, so how does R work? Now, the first thing in any coding is that you're telling people RStudio, where's your directory? Because the directory is where I've stored my data. So that's pretty standard, right? And then what you do is you press run out here and it runs. Now, as in any software language these days, what you have to do is you have to install and load packages, which then become your library. So think of it this way, is that, when you have a calculator, everything is loaded onto you. The division, the subtraction, multiplication, taking square roots, trigonometry, all those functions are loaded already. But when you use these type of packages, the packages don't come with all these functionalities loaded because you have a huge number of functionalities. So the more you add, the more space you take up on your computer. So what you have to do is that I've already loaded them up, but when you see something which is library here or install, that tells you that it's basically I've loaded a functionality which then allows me to do the calculations. Okay, so that's what the logic is. So I'm going to start off simply. So if you remember the variable which I had was, the sheet which I had was all data. It's a CSV file. So R can recognize CSV files, and I want a summary. So you always use a summary because you want to make sure that you're reading your variables in well. Okay, so all I'm going to do is I'm going to highlight it with my cursor and then run. And voila, there you go. So you see that R has read in my CSV file, and it's giving me automatically the summaries for each of the variables. So if you look at the poverty rate, this is a min value, the median, mean, the maximum value of this variable in my data set. And the similarly for the minimum wage, right? All the variables I have in my data sheet. So what the lesson you should take from this is that, I can go to Excel, I can then highlight the column, and then I could put a function in and get the mean and median, but it's so time consuming, especially if you have a large data set. And the advantage with something like R is that it just happens, okay? You can just get it immediately. It's so efficient. So then here, what I'm doing is that I'm not going to get into details in this. This is just, I'm telling R that, by the way, here are the variables that are numeric. Numeric as opposed to character. Character is like letters, right? So these are the variables which are numbers. So I'm just going to run this. Okay, now what I want to do is that, okay, what's the story out here? Let's start off simple. Okay, so let's start off as we started off in the tutorial. What is the correlation between the poverty rate and minimum wage when you take all the data from these provinces for all these years? So it's pretty simple. I just type up core, open brackets, and here I'm telling it that give me the correlation between the poverty rate, which is in this data set, and minimum wage, which is in this data set, right? So what's flexible is that I could have these variables in different sheets, and all I'd have to do is tell R which different sheets they're in. So it's extremely flexible. So again, highlight it, and then bingo, look at that. It tells me that it's negative 0.33. So there is a negative relationship between minimum wage and poverty, but it's not that high, okay? And you know what? Now, I want to look at some cool visuals, very simple, okay? So in R, there are functions called plot and ggplot. And this may seem a bit complex, but it's not. And let me just start off with plot. What am I trying to do here? Well, let me just try first show it to you. Oops, sorry. I didn't highlight it properly. Run. And then let me put plot. Let's see now. So now you see a really nice visual, okay? So what it is that I'm just increasing the size so you can see it. So you see the command out here. I'm telling R, give me a scatter plot. Like I want to see all the observations in my data set. And you know what? Here's the title. So here's the title. And then on the x-axis is the minimum wage. And the y-axis, it's the poverty rate, right? I just can call it anything I want. And I want a line through it. So this now gives you an idea of why there is a negative correlation. Like you take all the observations, the essence of regression analysis is just fitting a straight line through. But you can see that the spread there's a bit of a spread out there, right? That yes, on average, you take data from 1990 to 2011 for the 6 provinces or 5 provinces, you see a downward trend. That as minimum wage is going up, it's driving down poverty rates. But you can see it's not clustered around the line. So if it's not clustered around the line, that'll give you a low correlation. So that's why we're getting a negative relationship, but it's minus 0.33. Okay, that was very useful. But now what I want to see are differences across provinces. So this is basically looking at, this is combining all the provinces, right? So now what I'll do is highlight this one here. And by the way, when you do it, you can download it. See this export function? If I want, I can save this as a PDF, which is so then, or save as a PNG or JPEG file, which I then can copy and paste onto my Word document, right? So now, with this ggplot, what I told it said, look, for each different province, and I'm saying give each province a different color, give me a graph which shows me the changes in the poverty rate over time. And again, as you well know in Excel, this takes a few minutes, but boom, with R, automatically a really nice looking graph. And with a bit more coding, I can make it even better looking. Okay. Now, there's also some more tricks out here. Suppose I want a different type of graph. Now, you see, again, with a simple 1-second command, I've just got a different visual. Maybe that previous figure was too clustered. So I still want to look at the different provinces, but I want to look at each province separately. And then you can do that for each year. So then you can see in Quebec, the poverty rate is falling somewhat steeply. You see a smooth decline in Alberta. In BC, what's interesting is that there's actually an increase in the poverty rate among lone parent households in about 2005, then there is a dip. And then similarly with Nova Scotia, there is an increasing trend and then decline. So basically there's some very interesting variation in poverty rates across these different jurisdictions. Not each province had the same experience in poverty reductions from 1990 to 2011. Okay, let's continue. So there are some other things we could do. So what I like to do is, this is another, again, a great visual. Okay, I'm just going to have to read this file in. Now, suppose I want to look at the correlations between all my variables, just like a big dump, right, of relationships. So then by telling R that, you know what, here's this matrix P, which consists of all these variables in this data set. I want the correlations. And guess what? I want you to give me the correlations in terms of a plot with numbers. So when I do that, look at that. This is just a really nice visual to have. So you have poverty rate, minimum wage, government transfers, and employment rate. So remember what I told you before, that we assume that minimum wage is the only factor that can affect poverty rates. Well, what about the magnitude of government transfers and employment rates? So with the correlations here, you can see that red means there's like, it's going the opposite way high, the deeper red you have. And the deeper blue you have, it's a positive correlation. So when I look at the poverty rate, it's interesting because the minimum wage, as we all know, is negative 0.33. And when you look at the effect of employment, So there doesn't seem to hardly any relationship between it. It's almost non-existent between higher transfers and poverty rates. But when you look at employment rates, it's not bad, negative 0.42. So before you go on to any regression analysis, this type of visual gives you an idea of which variables might be important, even before you start your regression analysis. And it's so easy to see that in this visually appealing manner. Okay, now what I want to do, the next step, let's go on to, we're making good time. I want to go on to regression analysis. Now, but before I do that, again, I want to stop for 2 minutes. I want to make sure that everyone is sort of okay. And if there are any questions on the coding I just showed you or the methods.
We do have a few people asking if there is a downloadable link for that data set that you just used.
No, unfortunately, it isn't. Again, it's a data set I've created for this program. Um, so yeah, but I see a question on CorePlot. Yeah, CorePlot is just like a library from R, easy to not download. So what I'll do is that, you know what, I will see if I can create for everyone registered on this. I'll see if I can't share the scripts just now, but if you want to play with it, I'll see if I can create a new script with a new data set, and I'd be happy to send it to everybody who's registered, okay? But I can't just share this one because it's proprietary to WattSpeed. Yeah, my pleasure. So honestly, you know what? Coding is so much fun. It's like you can do it. I sometimes do it in my spare time just to, oh, this is an interesting problem. And let me see what I can get in terms of relationships out here between a y and x variable. So what I'll try to do is that I'll try to create something which is kind of a general frame, a shell, and then you can use it in your own analysis. Okay. So yeah, my pleasure. Okay, so I see that everyone's more or less okay. Now what we're going to do is we're going to look at regression analysis. Now is the fun stuff. Okay, let me share. Oops, sorry, I'm just having a trouble locating the, no. Ethan, can you see my R?
You are screen sharing the Zoom call right now, so you'll have to try again.
Yeah, no, this is odd because like suddenly I cannot, it's not coming up. And I'm not sure why. Okay, so let me try again. I think I may have. Let me try again. Yeah, okay. It's because I minimized the RStudio. Okay. Okay, can you see it now?
Yes.
Thank you. Okay, so now what I'll do is that when you run your regression analysis, right? In R, what you do is that you give your regression a particular name. So I'm just calling it, you can give it any name you want. So I'm just calling it lm.data1. And that's equal to, so LM is basically linear model. So you say LM, open brackets, poverty rate. So that's your dependent variable. And what is the effect of the minimum wage? And then I'm also telling R, the data is from this data sheet. Okay. So there, I highlighted it. And the other thing about R is that if I put this hashtag there, R knows that this is not a statistical command, but when you think about coding hygiene, it's not. This is not the best example of a good script. What you want to do is that you want to be kind of as copious and comprehensive in your notes as possible, because if the idea is that you're sharing your code, then there's a certain art to that, that you want to make sure that people know exactly what you're doing without spending hours trying to decipher like uh, what the process is, how you started, what is the objective of your research. Okay, so um, simple command, run. And so when you do that, you see that the regression output here. So this is similar to the example which we did in just visually when you looked at the Excel sheet. That on average, this is the coefficient estimate of your beta 1, right? So your beta 1 tells you that um, on average, as the minimum wage is going up by $1, then the poverty rate is going down by around 5 percentage points. So that is an effect. But there are a couple of things, there are a couple of other points which you want to take into account. That's not the end of your analytics. The other key statistic in regression analysis is what we call the adjusted R-square. So the adjusted R-square, in a sense, is just the squared term of the correlation, right? So it lies between 0 and 1, and the closer you get to 1, you'll never get to 1. If you get to 1, then there's something wrong in your coding. But the closer you get to 1, the better the model is fitting the data. Because at the end of the day, this is just a model, right? And we're saying that poverty rates are explained by the minimum wage. But you see a number of 0.1. The simple way to explain this is that this specific model is explaining only 10% of the variation in poverty rates. So that's something to be cautious about. The other variable, which you see out here, is called the t-value. Now, this is where distributional statistics and property distributions play an important part. Now, of course, we don't have time to get into that. So what the essence is that your t-values tell you how statistically significant this estimate is. Okay, and you only take the absolute value. You don't care about the negative sign out here. So if you have a high t-value, that means that this coefficient estimate is reliable. That means that if you went out and redid your analysis with more random samples of data, you'd pretty much get the same result. So generally, if you have, there are a lot of caveats here, okay, unfortunately, and I can't get into details. But if you have a large enough data set of 100 or hundreds of observations, typically, if your t-stat is equal to or greater than 1.96 in absolute value, that means your coefficient estimate is significant at the 5% level. That means that if you're to replicate this with 100 more times with different samples, 95 out of 100 times, this is reliable. This is critical. This is perhaps, the most important metric you'll use in regression analysis. A regression where, you have large coefficients, but your t-values are small, it's pretty useless. It has no meaning. So as a statistical researcher, if you want to, like, if you're looking for meaningful relationships, right, in your data, the first thing is that, does the sign of your coefficient estimate make sense theoretically? So, this is something which we as social scientists bring into the world of statistics and data science, right? So if you ask someone who is trained, and Elias will get more into it later in the afternoon, but a computer scientist, a pure data scientist, is not interested whether or not a sign makes theoretically, a sign is consistent with the theory, behavioral theory, right? So we have a negative sign out here, which is telling us the minimum wage is going up, poverty is going down. That makes sense. The data scientists would just take regression analysis, pour a lot of stuff into it, and whatever the signs are, the signs are. But if you can then use that equation, right, which to predict future values of poverty, that's all I care about. That's the data science perspective. In social science, that's not the case. The signs have to be right. So in terms of research now, we're really at an interesting point where the social scientists and the data scientists are trying to come together and discuss these issues, like how important is these type of theories to make sure the results correspond to theory when you run your results. So the signs have to make sense. The t-stats have to be high, above 1.96, and your R square, the closer you get to 0.6, 0.7, that's good. Okay. So now let's look at this equation. Now, how is this equation different? This equation is different because in addition to the minimum wage, I've added government transfers and the employment rate. So now it's really, interesting. Is this effect of the minimum wage, which is statistically significant and negative, is it at all going to change when I add in other variables? Okay, so let's run it and find out. Okay, voila. So let's see. Now, what you see is, first look at the fit. Now, the fit has gone up by quite a bit. Now, this is pretty good, right? It's 0.73. So this simple model, relatively simple model, is explaining about 70% of the variation in your dependent variable in teen employment rate. Sorry, oops, wrong. Oh, this is interesting. Okay, you know what? I'm looking at a different variable. Okay, I will, so the dependent variable out here is teen employment rates, so not the poverty rates. Okay, let's review this. So what is the effect of the minimum wage on teen employment? So unsurprisingly, as the minimum wage goes up, teen employment goes down, right? Maybe employers are substituting away from teens to more skilled employees because the minimum wage are making teens relatively more expensive. Now, is this significant? Yes, it is. It's got a pretty high t-value. Now, government transfers don't seem to matter. The employment rate matters. Look at that. what the way to kind of interpret this is, first it's got a positive sign. So it tells you that as the economy is more healthy, right? As employment goes up, then teen employment goes up. That's not surprising. And the T value is extremely high. Okay, so now what I'll do is that I'll rerun this. So just copy and I'll go down. And let's see the effect of the same model, but on poverty among low-income households. So once I type something in, R, you can see automatically has an autofill, okay, which is, again, very efficient. So I'm going to give it a separate name so as not to confuse myself. And let's run it. Okay, so this is interesting that this model, while explaining variation in teen employment rates, doesn't explain the variation in poverty rates among lone parent households that well. Better, if you remember that when we just had the minimum wage, the adjusted R square is 0.1. Now it's 0.3, okay? What's interesting is that previously the minimum wage coefficient estimate is about negative 0.5, 0.3 or something. It's not changed that much, even with the addition of more variables. And the T-stat is still pretty high. Now, but you see that the other variables are also important. As government transfers go up, that's telling you that the poverty rate is going down. So government transfers do matter. And the T-stat is actually absolute values, 1.99, basically 2, so that's significant. Now, this is somewhat interesting that as I'd expect as the employment rate is going up, yeah, no, actually, this does make sense, sorry. As the employment rate is going up by 1 percentage point, the poverty rate is going down by about negative 1.3. So pretty powerful effect, multiplier effect out there. And the T value is negative 6, so it's really high. So how would you then summarize these results in terms of a story, right? So in terms of a story, what you do is that this is how we began our journey today in the morning. We wanted to find out if there's any relationship between the minimum wage and poverty rate. When we looked at Ontario and Alberta, we found that there is some relationship out there, just visually looking at the data and looking at the correlations. Then what we said that we wanted to do something a bit more rigorous, regression analysis, which is the foundation for machine learning and a lot of data science. So when we did that, yes, when you use minimum wage by itself, you have an effect. But as a researcher, that's not satisfying because we know that independent of the minimum wage, there are other factors there which can affect variation in the poverty rate. And so we put in government transfers and the employment rate. And what we find is that the minimum wage variable still stays robust. It's a negative relationship, statistically significant. Government transfers matter, employment rates matter. Their signs correspond to what we'd expect theoretically, and they're statistically significant. But the fit of the model is not that high. It's 0.32. We want to get to 0.6 at least, right? So since it's 0.3, what we do is that we'd say, let's be cautious about these results. Let's be careful. And we acknowledge that there are, some variables out there which we haven't captured, right? That there are other factors out there we could probably include on on the right hand side. Okay, good. So in the time we have left, what I want to do is I want to show you a case study. Okay, and now I will go back to the Learn site. Oh, there, sorry, it just took a bit time to load. So I want to look at a case study. So this is stuff which I think there's a lot of Health Canada and public health agency folk out here. So I've done quite a bit of research on COVID, which I've published, and give you an example. So the example which I have is looking at the effects of population mobility in Toronto. And I've looked at provinces, different cities in Canada. But so this is kind of based on this paper I published with different co-authors from the University of Waterloo. It's in Canadian public policy. But the idea with Google, so just to give you a quick spiel, is that, and I'll spend more time on this after our break, but during the pandemic, Google basically released mobility data, which is based on mobility on Google Maps, right? If people turn Google Maps on their phone, then Google aggregated it and reported mobility patterns for different local areas. So you had it for provinces, and for Ontario, you had it for public health units. And what I'm interested in is looking at mobility in retail and recreation venues, grocery stores, and workplaces. Okay, you also have residences, for example. But the purpose of the research was that, look, when you had restrictions ease up and lockdowns ease up, and you had more mobility at these more communal public places, do you find a correlation between um, uh, uh, between population movements and daily cases? So at that time, the government of Canada, like all governments, didn't have any mobility data. And it was really good that Google made their data publicly available, um, daily values, so you could match those values to daily cases. So the model which I had was really simple, that if you look in Toronto, look at the daily cases in Toronto, right? And the daily cases today is a function of daily cases yesterday. That's what the T minus one value is. But it's also a function of how much mobility you see at retail places, how much mobility you see at workplaces and grocery places. And the idea here is that, what type of mobility led to increases in COVID cases? I mean, that's what's interesting. Was it like workplace outbreaks at retail outlets or grocery stores? What is more important as people slowly went back to their usual business, right? So I'm running out of time now, but this is the case study we're going to start off with at our next session. And what we have about 5 minutes left, and what I'd like to do is ask if you have any questions based on what I've taught so far.
So at this point, we are a little bit past when this question was asked, but somebody made a comment on government transfers potentially not being statistically significant, the variable, when you were running your model. I don't know if you want to comment on that. I think you might have covered that when you were going through it and had the realization.
Yeah, exactly. That was like that's because it is a wrong variable. That is when the dependent variable is teen employment rates.
Gotcha. And then Elias has asked, in our model, we see the minimum wage and employment are significant. What happens if we made a model that explored the impact of just government transfers on teen employment? Should we make that kind of model first?
That's a really good question. I think we could do it, but at the end of the day, what's important is what you get at the end. So you can do that as exploratory analysis, but at the end of the day, when you have all the variables on the right-hand side, you're making them fight to see which is significant. I think that's what's important.
And one more question that's come into the chat. Can you explain again what the purpose of adding the other variables is in the regression code? By adding them, are they controlled for, or are we looking at them in combination with the minimum wage variable?
Yeah, it's a great question. It's a bit of both, right? The way it depends on how you position your analysis. Like, if the objective is, I think it's more the exposition. We are, by including all of them, making them fight it out to see which ones remain significant at the end. But the way I've kind of formulated this as an exercise is that our focus is in the minimum wage as a researcher, and I want to see if minimum wage, excuse me, remains robust after we add all these controls. So it's more of a control in this case.
And another question that's just come in, I've seen use of both OLS and LM function for linear regression. Do you find that there's a difference between the two?
That's good. I don't think there is. I just basically use LMs because I find that a lot of the code which I want to use after that is linked with nice examples to them, but I think they're the same thing. Okay, so I think we're at time then. So, Ethan, you will conduct the survey and let me know if people want to come back on at. So, if people want office hours at 1 o'clock, but other than that, I will let everyone go and get a half an hour break, catch up on your email, and we'll be back at 11 o'clock then.
Sounds good. So I will launch a poll, as Anando has just mentioned. This is just going to gauge interest if we want to have people come back at 1 o'clock. And I'll leave that running during our break here that we have for half an hour. So feel free to answer that. And we will see everybody at 11 when we regroup.